All right, so let's quickly go through these here, guys. So our first one, we've got a single replacement reaction between an ionic compound and a non-metal. That means that the non-metal will replace the non-metal, and we will wind up with BeBr2 plus sulfur. And sulfur is very special, okay? Comes as an 8. So here's the marks distribution. They have this compound, BeBr2, 1 mark. S8, 1 mark. Okay, so 1 mark for each of the products being predicted correctly. Now they got to balance. That will be the 3rd mark. All right, there's 8 sulfurs, so we need an 8 here. That gives me 8 beryllium. All right, so I go over here and put an 8 there. That gives me 16 bromides. Okay, and now everything is balanced. So 8, 8, 8, 1. Okay, that's their 3rd mark. Questions on number 1? They don't need the 1. Okay. All right, for number 2, I've got a non-metal reacting with a metal. That creates what kind of compound? Okay, it's a synthesis reaction. It produces what kind of compound? An ionic compound. What do you write first in an ionic compound? The metal. Did I tell you about this one before? Okay, I warned you about it. Okay, K goes with N. This is a -3. This is a +1. K3. N. Give them 1 mark if they have that. So question number 2 is actually only going to be out of 2 marks. Okay, and now we have to balance. Right? We've got 2 nitrogens over here, but only 1 over here. So I'm going to put a 2 there, and that gives me 6 potassiums. Okay, so blank 6,2 or 162 is your balancing. 2 marks for that one. Okay, questions on number 2. Right, and guys, it must look like this, K3N. It can't be NK3. It has to be K3N for that mark. All right, 3rd one, double replacement reaction. In a double replacement reaction, we swap the metals. So copper ends up with hydroxide. Sodium ends up with sulfate. We have to swap and drop everything. Over here, copper has a 2+ charge because sulfate is -2. So over here, copper also has a 2+ charge. 1 mark if they have CuOH in brackets with a 2 outside the brackets. If they don't have the brackets, it's not right. Okay, and then we have NaSO4. This is +1, this is -2, so we have Na2SO4, 1 mark for that compound being predicted correctly. Right, then we have to balance. We got 2 hydroxides over here. Now we have 2 on this side. That gives us 2 sodiums. Now there's 2 on that side. Everything else is a 1. Okay, 1 mark for the balancing, 1 mark for each compound. Questions on 3? All right. Number 4 is a combustion reaction. Okay, combustion reactions always have these 2 products. 1 mark each for carbon dioxide and water. Okay, for balancing, I have to use both rules for this one because 4 is an even number. So I balance alphabetically and apply the rule of 2. 2 times 4 is 8. Okay, 2 times 10 is 20. 10 times 2 is 20. 8 times 2 is 16, plus 10 more is 26. 13 times 2 is 26. Okay, so 1 mark for each compound, 1 mark for the balancing. Questions on number 4? Okay. And then for number 5, single compound, that's a decomposition reaction. So we're breaking down into manganese and chlorine. Manganese is a metal, and there are no special metals, but chlorine is special and must be a Cl2. So 1 mark for Mn, 1 mark for Cl2. And then to get this whole thing to balance, you need a 2 there. So 1 mark for those balancing numbers. The whole quiz is out of 14. So count them up, give them a mark out of 14, let them see it, put it in the box. Then back to your desk, we'll talk about the lab. All right, a couple of things when we get across the hall to the lab. Okay, first thing that you need to do is grab yourself a lab apron and the safety goggles out of the drawer for your area. Okay, you can take the seats down from there. Okay, but make sure you've got your goggles on and your apron on as soon as possible. Okay, all the stuff you're going to need is at the front, okay, on the main teacher's table there with the sink. Right, there's the watch glasses are kind of over on the far left side. Well, if actually for you guys, because you're looking at it, will be your right side. Okay, the thermometers are right beside them, and then all of the unknowns, okay, are strewn across the table. Now, each unknown has has either a scupula in it or it has several eyedroppers in it. The eyedroppers are labeled. That means you must make sure your eyedropper gets back in the right container. So make sure it matches what it says on the eyedropper. Now, they don't always stay on there. They get rubbed off with people's fingers, but we do our best to kind of make sure that they always get back in the right place. The other thing you have to be careful of is when you're mixing them. So what you're going to do is you'll put the first thing, like let's say you're pairing up A and B. You'll come up to the front and put A in the watch glass. Okay? And then you'll fill the eyedropper for B up. And you'll tip it upside down so it can't leak out and walk back to your station with the watch glass and the eyedropper full of the second reactant. All right, everybody with me there? Otherwise, everybody's at the front doing the reactions, and it's a gong show. Okay? So you come back to your station with both reactants separate. Okay? When you get there and you mix them, make sure you're ready. Make sure the thermometer is in the mixture so it can record any temperature changes. Right? And make sure that you've already looked at what did they look like before. Okay? Make sure you have your before observations done. Are they both clear? One was a solid, one was a liquid, whatever. Okay? Make sure you have those written down and then mix them. The thing you need to be careful of when you mix them is that you don't get the eyedropper in the reaction. All right? Inevitably, I have that happen. Okay? People will squeeze them together and they've got the eyedropper down, and as soon as they let go of the eyedropper, it sucks up all of the reaction. Okay? And then they go and put it back in the original container and contaminate the whole thing. All right? So please make sure that you've got them separated and that you keep them separated. If you know you've contaminated the eyedropper, it isn't the end of the world unless you bring it back and contaminate the rest of the solution. Okay? If you just say, Mr. Coderre, look, I messed up and this thing is full of that stuff now, that's fine. We'll throw that one out. We'll go get another one. Okay? They're not expensive. All right? We'll just get another one. We'll replace it. Let's just make sure that nobody contaminates any of the original samples. Okay? Everybody follow me there? All right? It really shouldn't take that long to get all of these mixtures done. We should be back in here, I'm hoping, at about 3:15. Okay? Now, the other thing is that other than 4 and 5, you can do them in any order. All right? But pair 4 and pair 5 have to happen right after each other. Okay? If you look at your procedure here, okay? Pair 4, you mix A and F, so that's sodium hydroxide and the phenolphthalein indicator. All right? So you mix those two together. Then you don't get rid of that. You keep it and you add C to it as pair 5. All right? So that's the only one where you have to go 4, then 5. The other ones you can do in any order. Okay? You could do 7 first if you wanted. And in fact, it's not a bad idea to kind of switch it up. That way not everybody's fighting over the same solutions at the same time. Okay? Does everyone follow me there? All right. The last thing, the zinc. Okay? The zinc solid, it's in a beaker. It's little gray metallic chunks. There's no scupula in there because you can just pick it up with your fingers. Okay, it's just a metal. It's not going to hurt you. Just pick it up and put it in the dish. Okay, and take it back with you. All right. Everything else, don't get on your fingers. All right. If you do, underneath the sink for at least 2 minutes, if not 5 minutes, depending on what it is you've touched. Make sure you tell me. All right, so that I can get the proper lab safety procedure going on there. All right. Questions? Okay. Let's head over then. Okay, so a couple of things here in regards to your observations. Okay, the observations, correct observations, are posted on my website. Okay, in the lab folder, all right, in the lab results or whatever folder there. Here, looks like. Okay, so if you go to my website, if you lose yours or you weren't here today or whatever, okay, go to Science 10 Notes and Assignments, Data and Observations for Labs, and you'll see Lesson 13 Reactions Lab Data there. Okay, just for the rest of us here, we're going to quickly confirm, okay, some results. Now, okay, for pair number 1, okay, how many people predicted that as though it was a double replacement reaction? Okay, and as I thought you would, okay, I kind of set you up a little bit here in that I know a couple of these don't go exactly like a regular double replacement reaction. What did you observe in that reaction? Caroline? Oh, I sure hope not. There was a really strong smell in that reaction, a very strong smell that you have probably smelled before if you've ever used Windex or any type of glass cleaner. Okay, you should have smelled the smell much stronger than Windex, but like Windex, right? If you smell something as a reaction is going on, what does it mean is produced? A gas. Okay, if you did this as a double replacement reaction, which most of you probably did, then you predicted the products to be two ionic compounds, and ionic compounds are not gases. Agreed? Okay, so there was really no way for you to get this one right. I set you up that way. All right, now I'm going to help you out a little bit. Okay, in that these are the products of that chemical reaction. Okay, we have NaCl, an ionic compound, table salt. Okay, we've got water, but we have NH3. The common name for nitrogen trihydride is ammonia. Okay, and ammonia is what is used to clean glass. It's what's in Windex. That's the gas that you smelled. All right, so those are the products, but you will notice I did not balance that reaction. That is up to you. Okay, part of your analysis is to write the correct reactions balanced. Okay, everybody with me there? Now, in number 2, how many of you predicted that one to be a double replacement reaction? Okay, and probably most of you did. But what happens in that reaction? Yeah, it bubbles and fizzes, right? It's vinegar and baking soda. We all know what happens. What gas is that? What gas is in those bubbles? CO2, right? CO2 is what's in those bubbles. So you're not getting, exactly what you thought you were going to get, okay, in a double replacement reaction. Instead, okay, you're getting this. Right? You're getting water, you're getting a salt, okay, an ionic compound, in this case sodium acetate, and carbon dioxide gas. Again, you will have to balance that one, okay, but I'm sure that you guys can figure that part out. Now, the reason that this one doesn't go quite the way a double replacement reaction goes is because it is an acid-base neutralization. Okay, sodium hydrogen carbonate is a base. Acetic acid is obviously an acid. Okay, when they react, always a salt and water are produced, but sometimes also a gas. And in this case, that gas is carbon dioxide. All right, so we have to be aware of that's what happened. Okay, remember that for pair 4 and for pair 5, you did not have to have any prediction. Okay, nor will you have to write those reactions in the analysis because, okay, they're a indicator reaction, and we haven't gone over those. All right, so you don't have to worry about writing reactions for 4 or 5. Okay, you do, however, have reactions that you have to write for 3, 6, and 7. Okay, you also probably noticed that in a couple of reactions you got precipitates. One of the analysis questions talks about those precipitates. Okay, so make sure that in question number 2 in the analysis here, okay, it says 2 of the reactions produce precipitates using the chemical equations you wrote. Okay, and you probably predicted those ones correctly. Okay, identify the precipitates formed in the lab. So look at your solubility chart, see which one of the products is not soluble. Okay, and then for number 1, again, number 1 is using words and formulae. So write it out as a reaction, like we have here, and then write it out with the names as well. That's question number 1, so I want to see both. Okay, a lot of marks available there for something that you guys are very good at already. Okay, okay, for each chemical reaction, right? And then you got your conclusion. Okay, so did you see the signs that you predicted in your hypothesis? Okay, the signs of a chemical reaction that we talked about the other day. Okay, and then your sources of error, identify them, tell me how they could be improved. Minimum 2. Okay, probably you can think of 3. Okay, and then the class discussion, you do not have to answer that. We will answer that when I hand back the lab reports. Okay, the lab reports are due on Tuesday, March 11th. So make sure you have them done for that day. All right. Questions on any of that? Okay, when you put this lab report together, There are 2 podcasts you need to watch. The one from yesterday, that's lesson 13, reactions lab, pre-lab, and then today's. All right, because I talk about kind of 2 different things. I talk about the pre-lab stuff, the hypothesis, whatever, in yesterday's, and today I talk about the analysis and the results. So make sure you watch both, okay, so that when you're putting it together, you don't miss anything easy, okay, or forget to do something. Everybody got it? All right, you still have about 5 minutes. You could probably be working on some part of your lab report right now, okay, at least on paper, and then you can transfer it to the computer later. This one is submitted on Google Drive only. Okay, so make sure you have it all typed and submitted to me, shared with me on Tuesday.